Alright guys, this is Miss Kissinger and welcome to your first video lesson. This is about the 17th time that I've tried to record this, so hopefully it works out this time. Alright, first thing we're going to do is pause your computer, and I want you to do questions 1 and 2. They are review from last semester, so you should be able to do them. If you don't remember what the distance formula is, look it up in your book now before you have to do the problems. Okay, when doing question 1, the first thing you should have done is look up the distance formula. So we have d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, we're going to do what we always do and label our points. So we have x1, y1, and x2, y2. Now this is not totally necessary, but it makes our life easier when we're trying to plug our numbers into our formula. So we have the square root of x2, which we found was 3. So we have 3 minus 1 squared plus y2, which is 1 minus 2 squared. Now we can say that equals 3 minus 1 is 2 squared plus 1 minus 2 is negative 1 squared. I'm going to go over here because I'm running out of space. So now I have 2 squared, which is 2 times 2, which is 4, plus negative 1 squared, which is negative 1 times negative 1, which is positive 1. So now I end up with the square root of 4 plus 1, which is 5 as my answer. Now, problem number 2. We need to do or figure out our slopes. So we have parallel slope. Parallel slope means what? Try to do it before I tell you. Hopefully you said the parallel slope means that the slopes, my m, part of my y equals mx plus b formula, are congruent. Now, for perpendicular, it's a little bit different. For perpendicular, our slopes are the opposite reciprocals. And neither is obviously neither congruent or opposite reciprocals. Let me remind you, opposite reciprocal. If I have negative 1/2 as my first slope, if I'm trying to find my perpendicular slope, then that means I'm going to be opposite. So this is negative, so that means I have a positive number, and my reciprocal means I'm going to flip my fraction. So I have 2 over 1, so that means my opposite reciprocal is going to be 2. So if they are perpendicular slopes, we will have something like negative 1/2 and 2. Now, what we need to do is put both of these equations in slope-intercept form. Slope-intercept form, as we all know, is y equals mx plus b. This one is already magically in y equals mx plus b, so now I just need to put this one there. So the first thing I need to do is I have negative 6x plus 2y equals 8. I need to get rid of my negative 6x because I want y by itself ultimately. Now, remember that little trick that I taught you is if we box this piece, we can't play with it until the very end. And we need that box by itself. So I'm going to since we're subtracting, we're going to add 6x to both sides. So now I am left with 2y is equal to 6x plus 8. Now, here's the thing about that. We still have a 2 stuck with our y, so in order to get rid of this, we need to divide each piece by 2. So now we have y equals 3x plus 4, which is awesome because now we're in slope-intercept form. Now, my two slopes. My first slope up here is 3, because remember our slope is our m piece. So we have 3 as our slope here, and the slope of our second equation is also 3. So 3 is equal to 3, which means that my slopes must be parallel. Okay, hopefully you remember that, but now we are moving on to section 6.1, classifying quadrilaterals. This is awesome because we already kind of know what a quadrilateral is. The first part of the word quadrilateral is quad, and we all know that means 4. So a quadrilateral is just a 4-sided polygon. Now, I know this is going to jog your memory a little bit, but interior angle sum formula. So if I have interior angle sum, my formula is n minus 2 times 180 degrees. Hopefully we all remember that. So I'm going to figure out my interior angle sum of a quadrilateral, which is 4 minus 2 times 180. So now I have 2 times 180, and for you skateboarders, if you do a 180-degree twist 2 times, that means we have a 360-degree twist. Now, exterior angle sum. Exterior angle sum is always 360 degrees. Always, always, always. You don't have to do any math. It's just when somebody asks you what's the exterior angle sum of a polygon, you can say 360 without even thinking about it. Alright, so now that we know every quadrilateral has an interior angle sum of 360 degrees and an exterior angle sum of 360 degrees, let's talk about our different types of quadrilaterals. Our first type that we're going to talk about, most basic type, is a parallelogram. A parallelogram, what you need to know is that it has opposite sides being parallel. So that means that the sides across from each other are parallel. So this side would be parallel with this side, and this side would be parallel with this side. Now, our next quadrilateral is going to be a type of parallelogram, which is a rhombus. Now, I already said a rhombus is a type of parallelogram, so that means we know that the opposite sides are parallel. Now, the other thing we need to know about a rhombus is it has 4 congruent sides. Now, the angles do not have to be congruent, but the sides do have to be congruent. Now, the other side of that is our rectangle, which again is a parallelogram. All of these so far have been types of parallelograms. So we have a parallelogram. And a rectangle, the thing we need to know about our parallelogram, is it has 4 congruent angles. So rhombus, 4 congruent sides, rectangle, 4 congruent angles. Now, we know our total interior angle sum is 360 degrees, and if all of our angles are congruent, then that means we know that each angle is 90 degrees, which is a right angle. So, more specifically, rectangles have 4 congruent angles, rectangles have 4 right angles. Now, the next thing we have is a square. Now, a square, again, is a parallelogram. It has 2 sets of parallel sides. Now, the parallelogram that is a square has 4 congruent sides and 4 congruent angles. So it has the properties of a parallelogram, a rhombus, and a rectangle, which is awesome. A square, awesome. Now, the next thing that we have, if I can make my screen scroll down, is a trapezoid. Everybody loves the trapezoid. The thing about a trapezoid is it has exactly one set of parallel sides. So, the thing we know about that is that we have a trapezoid. We all know what it kind of looks like, and it kind of looks like this. And we know that it has one set of parallel sides, so that means this side is parallel to this side. We don't know anything about these sides. They could be perpendicular, they could be neither, it doesn't matter. Just these 2 sides are parallel in order to be a trapezoid. Now, there is a fancy type of trapezoid, and it's called an isosceles trapezoid. Isosceles trapezoid. It still has exactly one set of parallel sides. The thing that we also need to know is that the non-parallel sides are congruent. So that means that in an isosceles trapezoid that this side is congruent to this side. It is a perfect shape. Now, our last quadrilateral that we need to talk about is a kite. Now, a kite, all we know is that the adjacent sides are congruent. Now, remember, adjacent. What does the word adjacent mean? Next to. So, that means that the sides that are next to each other are congruent to each other. Got it? Okay, now we're going to move on and talk about all of our different parallelograms, or all of our different quadrilaterals, parallelogram being the first one, and their properties. Now, we know the properties of a parallelogram is that both pairs of opposite sides are parallel. We discovered that on the first sheet. Now what we're going to do is mark up our picture because we need to know what all the symbols mean. So we need to know that this side is parallel to this side. Now remember these little arrows mean parallel. And we also know that this side right here is parallel to this side. Now, the reason I use two arrows on these two and one arrow on these two is because parallelogram does not mean anything about congruency. We just want to know that this is parallel to this, and if I label this one with one arrow, then that means I'm saying that these two are parallel, which is obviously not true because they intersect. Okay, now, moving on to our second quadrilateral, which is a rectangle. Now, a rectangle uses all of the properties of a parallelogram, which means that we have two pairs of parallel sides that are opposite of each other. So this side is parallel to this side, and this one to this one. Now, we also know that the intersecting sides are perpendicular. So that means that the intersecting sides intersect at right angles. And we mark right angles with our little box. So we have right angle, right angle, right angle, right angle. Okay, now let's move on to the rhombus, or rhombi if we are talking about multiple rhombuses. Okay, so a rhombus has all the properties of a parallelogram. Meaning, we have two sides of two opposite sides are parallel. I'm going to drill this into your brain. So we have parallel, 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 parallel. Now, the other thing we know is that we have four congruent sides. So let me get another color. We can say that this side is congruent to this side, which is congruent to this side, and this side. I know it might not look like it, but all of these sides are congruent, and that is what we know about a rhombus, is that they have it's a parallelogram with four congruent sides. Now we are moving on to the square. Notice that this says all properties of for all three of our properties, which means that it is a combination of three different quadrilaterals. So, square has all the properties of a parallelogram, which means we have this side being parallel to this side, and this side being parallel to this side. And we have all the properties of a rectangle, which means we have a right angle here, and a right angle here, right angle, right angle, because remember the properties for a rectangle is that all of the angles are right angles. And lastly, we have all the properties of a rhombi. Now, a rhombi says that all of my sides are congruent. It's a parallelogram with all of my sides congruent. So I know that this side is congruent to this side, and this side, and this side. Okay, now we're moving on to the fun ones. Trapezoids. Trapezoids are my favorite. The thing that we need to know about trapezoids is that exactly one pair of, or it has exactly one pair of parallel sides. So that means that this side is going to be parallel to this side. That's all you need to know about a trapezoid. We don't know anything about these being parallel. They are just regular lines connecting our two parallel lines. Now, moving on to our special type of trapezoid is our isosceles trapezoid. Now, our isosceles trapezoid has all of the properties of a trapezoid. So we know that this side is parallel to this side because there is exactly one set of parallel sides. We also know that our non-parallel sides are congruent. So that means I know in an isosceles trapezoid that this is congruent to this. You can also remember this because if we have an isosceles triangle, that we know that these two sides are congruent. Same type deal with the trapezoid, except we just cut the top off. Our last shape that we are going to talk about is a kite. Now, properties of a kite is that it has two pairs of adjacent sides that are congruent. So that means that this side is adjacent to this side and they're congruent, and this side is congruent to this side. Now, here's a little note, because if you do this in class, I'm going to freak out. It is not called a diamond. A diamond is a stone. A diamond is something that I wear on a ring. A diamond is something that you wear in a necklace. This is a kite shape. Now, since the definition of a kite says that there are two pairs of adjacent sides that are congruent, we can also draw a kite that looks like this. We have adjacent sides that are congruent, and then it could be concave. So I could have, sorry, my picture is not awesome. This side is congruent to this side, and this side is congruent to this side. Now, these two sides are adjacent and they are congruent, which matches our property, and these two sides are adjacent and congruent. Now, remember adjacent means next to. Do not forget this. We have adjacent angles that we learned last semester. Now we have adjacent sides. They are just sides that are next to each other. Okay, I know you're probably getting tired of listening to me, so the last thing we're going to do is our quadrilateral family tree. I promise this is the last thing that we're going to do. So, first thing, top of our family tree is quadrilaterals. Now, it's the family tree. This is the top dog. Okay? Now, going this way, we are going to say has two pairs of congruent adjacent sides, which leads us to our kite. Now, this way we're going to say has one pair of parallel sides, and if we go this way, we have two pairs of parallel sides. Now, back over here, quadrilaterals. All of our quadrilaterals that have one pair of parallel sides are trapezoids. And we have, I bet you can guess, off of a trapezoid, we have the isosceles trapezoid. And over here, quadrilaterals, two pairs of parallel sides. Our first one and main one is our parallelogram. Parallelogram. And if we go this way, we have what I hope you can recognize as a rectangle. And over here, all of our sides are congruent, which means we have a rhombus. And our properties for our square come from both the rectangle and the rhombus. So we have congruent angles and congruent sides, which gives us a square. And this is your quadrilateral family tree. Thank you, and I'll see you tomorrow ready to work on your homework.